Hello student, welcome to my class. Today we are going to discuss about some numerical based on refraction through glass slab. What is the relation between apparent depth and real depth, and what is critical angle? Clear? So first we will go for the first problem. And a ray of light passes from air to glass medium and of refractive index mu equal to root 3 at an angle of 60 degree. Calculate the angle of refraction, deviation and speed of light in glass medium. Clear? That means suppose we have a glass here, then here a ray of light which incident in air medium, and this is glass medium of refractive index here mu equal to root 3, and which incident on the glass at an angle of 60 degree, the incident ray, and this is actual path or line of action of incident ray. But when ray of light traveling from rarer to denser medium, it bend towards normal. So this is refracted ray, and this angle is known as angle of refraction, and this is deviation because this is original path and deviates from its original path. Suppose this angle is known as angle of deviation delta. So if we use Snell's law at point A, by using Snell's law, if we come across the solution part, Snell's law, what is Snell's law? That is sin I by sin of angle of incident divided by sin of angle of refraction, which is equal to refractive index, that means relative refractive index of second medium with respect to first medium, or we can write that is mu 2 by mu 1. If we cross multiply this, then we can write that is mu 1 sin I equal to mu 2 sin R. You have to remember this relation where mu 1 sin I means it is based on the incident ray. That means incident ray traveling which medium, this factor depends on that point. So here another factor, that is mu 2 sin R. This is refracted ray. This term for refracted ray. So this is incident ray. So if we use here, we have to use this formula here, incident ray, and according to this formula, refractive index of air medium, we already know mu equal to 1, and this is mu 1 and this is mu 2. So mu 1 sin I, mu 1 means 1 into sin I, sin of angle of incident, which is equal to 60 degree, equal to mu 2 refractive index of second medium, that is root 3 into sin R. Clear? Now use the value here, that is the value of sin 60, that is root 3 by 2 equal to root 3 into sin R. Root 3 cancel, is 1 by 2 equal to sin R, and the R equal to, what is 1 by root 2? Sorry, 1 by 2, but we already know the value of sin 30, which is equal to sin 30 degree, and R equal to 30 degree. So angle of refraction R, this is angle of refraction R equal to 60 degree. Clear? Next, what is deviation? Because this is actual path or line of action, this total angle which is equal to, can we write, this is angle of incident, this is angle of incident I equal to this two angles, sum of this two angle R plus delta. So angle of deviation can be calculated I minus R, and here 60 minus 30 degree, which is equal to 30 degree, which is equal to delta. Clear? So here angle of deviation delta equal to 30 degree. That means the incident ray deviate from its original path at an angle 30 degree. Next, speed of light in glass medium. We already know refractive index of second medium with respect to first. Second medium with respect to first, which is equal to, it is the ratio of speed of light in vacuum divided by speed of light in that medium, and suppose V. And this relation can be write, that is mu 2 divided by mu 1, and this is for air medium, or we can simply write mu equal to C by V, and here V equal to speed of light, that is C by mu, which is equal to here, that is C speed of light and its value 3 into 10 to the power 8 meter per second divided by refractive index of glass medium, which is equal to root 3. And if we solve 3 root 3 divided by 3 into 10 to the power 8 meter per second, and which is equal to 3 cancel, root 3 into 10 to the power 8 meter per second. This is velocity in glass medium. Clear? So by using this concept you can solve different type of problem. Next, question number 2. This is question number 2. A ray of light is incident at an angle of 60 degree with the normal 2a root 3 centimeter thick plate of refractive index mu equal to root 3. Find the shift in the path of light as it emerges out from the plate. That means we already discussed in case of glass slab and what is lateral shift. That means if angle is much greater, incident angle and angle of refraction is very large, at that time we can use the lateral shift case. So in this case, this is air medium, and you already know refractive index, that is 1, and another medium, this is ray of light incident at an angle normal to a thick plate. Okay, so it's given that its thickness of the plate, that is T equal to root 3 centimeter. Clear? When a ray incident at an angle of 60 degree with the interface separating by two medium, this is the line of action of incident ray. Clear? And we already know the formula. This is angle refracted ray, and when a ray of light traveling from denser to rarer medium, it bends away from the normal like this, and this distance is known as d, and d is known as lateral shift or lateral displacement from its original path. We have to find this distance d. Already have relation, that is d equal to t by cos r into sine of I minus r. This is formula for lateral shift. Here we have to find lateral shift. So here there is a relation r. What is r? R means this angle of refraction. So first we have to find angle of refraction at this point. Suppose this point A. At point A, if we use Snell's law, that is mu1 sin I, which is equal to mu2 sin r. What is mu1 sin I? Means angle of incident traveling which medium, angle of refracted ray traveling which medium. This is second medium and this is first medium, and its refractive index given that is root 3. Now if we use mu1 is here 1 into sin I sin 60 equal to, and same thing here, traveling from 60 degree to this medium, then we get, that is, if we write again root 3 sin r, the value of sin 60 root 3 by 2 equal to root 3 sin r. Root 3 cancel, so r equal to 30 degree. This is angle of refraction, we get that is 30 degree. Now use this relation, d equal to t at the value of t, which is equal to root 3 centimeter divided by cos r. Cos r means cos 30 degree into sine of 60 degree minus 30 degree. Now use angle of incident and angle of refraction, which is equal to 60 minus 30. Then this relation can be right, that is root 3 into the value of sine 30 degree, which is equal to root 3 by 2, and here that is root 3 by 2 into this is sine 60 minus 30 equal to 30 degree, and hence its value root 3 cancel and 2 multiply 2 into that is sine 30, and the value of sine 30 which is equal to half, and 2 cancel, so d equal to 1 centimeter. Clear? So it displaces or lateral displacement of an incident ray from its original path, that is 1 centimeter. Clear? Now next start question number 3. A pin laying on a table is viewed from a distance of 1 meter of a glass slab of thickness 12 cm and refractive index of the glass slab 3 by 2 is placed on a pin. What is the distance of the image of the pin from the eye? Before start this question, suppose there is a surface and this is suppose water medium of refractive index, any other medium refractive index √3, and there is a object laying on the bottom surface. Here this is object O, and suppose this distance is 12 centimeter. Clear? If we observe, this is air medium, and if we observe from this side or air medium, now find the apparent depth. And in this case we already discussed, that is d dash by d, apparent depth and real depth of the relation. D dash, or we can write this is apparent depth, that is apparent depth divided by real depth, which is equal to d dash by d equal to refractive index of second medium with respect to first medium. What is first medium? First medium means incident ray traveling which medium, this is first medium. Second medium means refracted ray traveling which medium, that medium is known as second medium. So this is first medium. There is a object, the light which incident initially and the light which incident perpendicular to the surface which travel undividedly, and another ray traveling this direction, but this ray should be paraxial, and if we draw a normal, now travel this direction and image appears to meet at this point I, and this distance is known as distance d dash, and this distance is known as d. This is real depth and this is apparent depth. So this is the relation between real depth and apparent depth. So in this case apparent depth can be written, that is d dash. So d dash equal to here mu2 by mu1 into d, and mu2 means refracted ray, and this is refracted ray, this is air medium of refracting index 1. So you can write mu2, this is mu2, refracted ray traveling which medium, that is the refractive index, that is mu2. So you can write here 1 by mu1 means this is the medium whose refractive index √3 into, and here distance equal to this is real depth. So here real depth equal to 12 centimeter. Now you can write that is 12 by √3 centimeter is known as, this is known as apparent depth. Or you can calculate also, find normal shift, or this object appears to reach this point and this distance is known as y. We already discussed about what is a normal shift. Y equal to this total distance d minus this distance which is equal to d dash, and if you use here this formula, there is 12 minus 12 by √3 which is equal to 12 into 1 minus 1 by √3 centimeter. Now you can solve this, then you will find the value of normal shift. Clear? So by using this concept we have to solve this problem. Here given that there is a object or pin which lies on a table. Suppose a pin lying on a table, suppose there is a table like this, and there is a pin point, suppose this point is object or pin. Pin lying on the table is viewed from a distance of 1 meter, is viewed from a, here solution part, if you observe here, then this distance from the point of observation which is equal to 1 meter, or this distance is 1 meter, or we can write that is 1 meter equal to 100 centimeter. Similarly, a glass slab of thickness 12 centimeter and refractive index 3 by 2 is placed on the pin. Now we have to place a glass slab here in this way. This is a glass slab which is placed on the pin, and its thickness of the glass slab given that is 12 centimeter. So question is that what is the distance of the image of the pin from the eye? What is the distance of the image from this distance? Suppose this object appears to meet at this point due to its refraction or apparent depth, then we have to find this distance this distance is known as the distance of the image. This is image, the distance of the image eye of the pen from the eye. First, so you have to first find the distance, and this distance is known as, that is d dash. And okay, if the distance is d dash, we have formula, that is apparent depth divided by real depth, which is equal to d dash by d equal to mu 2 by mu 1. We already discussed all the distances are measured from its surface. From this surface. Surface means the surface which separating by two medium. This is air medium and this is glass medium. So here, if we use this concept here, first we have to find this distance. This distance is known as real depth. For if you find the apparent depth d dash, so here real depth, that is d equal to here 12 centimeter. Imagine that we observe from this point, not this 1 meter. If you observe 12 centimeter, then at that time d equal to 12 centimeter, and we have to find d dash. Clear? Okay. And this is medium number 1, because here incident ray traveling, because there is object, so incident ray traveling which medium, that is refractive index mu1, and what is mu 2? The refracted ray traveling which medium? This is air medium for refractive index mu1. So here, that is mu1 equal to, mu1 means refractive index of glass slab, given that is 3 by 2, and refractive index of air medium we already know, that is 1. If we use this concept, then d dash equal to, that is mu 2 by mu 1 into d, and its value mu 2 equal to 1 by 3 by 2 into d, distance which is equal to this distance. If you observe this point, ignore all the conditions, if you observe this point, then real depth which is equal to 12 centimeter, and here 2 by 3 into 12 which is equal to 3 4 12 and 4 2 8 centimeter. This is d dash. D dash means apparent depth. So this distance we got, which is equal to 8 centimeter. Okay, but we have to observe at a 1 meter distance, which is equal to 100 centimeter, and this object now appears to reach this point, this distance. Clear? If this distance 8 centimeter, then we have to find this distance, because total distance 12 centimeter. If this distance 8, then this distance 4 centimeter. But this total distance from observer to on the table or object, this total distance which is equal to 100 centimeter. Now we have to cancel this distance 4 centimeter. Clear? So distance of image, of the pen from eyepiece or observer, which is equal to, that is 100 centimeter minus 4 centimeter is equal to 96 centimeter or 0.96 meter. Clear? This is the relation. So this is the distance from observer to object. Clear? Okay. Now next question here. What is the apparent position of an object below a rectangular slab of glass 60 centimeter thick if a layer of water 4 centimeter thick is on the top of the glass, given that refractive index of glass 3 by 2 and refractive index of water which is equal to 4 by 3. Now we have to solve what is the apparent position. Clear? Apparent depth first we have to find here. So according to question, there is a object and which lying on the surface, any surface. This is object O. Now if an object is below a rectangular block of glass, this is rectangular block of glass, and its thickness given that this thickness which is equal to 6 centimeter. If a layer of water. Now use a layer of water here. This is water layer and this is glass. This is glass and this is water layer. 4 centimeter. This is 4 centimeter on the top of a glass. Then we have to find apparent depth. If we observe here observation point. Clear? Now we have to find the apparent depth, or we have to find the distance of object which raised, or raised distance, or normal shift. Here we have to find. So first we have to find normal shift, or this is apparent position from the surface of observer. Clear? So this is air medium and this is denser medium, and this is also denser medium. So in this case ray diagram is important. The ray which starting from the object and incident, normally it travel undeviatedly in this direction. Clear? This is angle also 90 and this angle also 90 degree. For first, imagine that for this surface, only one surface, this surface, and here if another ray traveling this direction and here incident here, but given that refractive index of glass which is equal to 3/2 and refractive index of water, that is 4/3, that is 1.3 and this is 1.5. So here the refractive index, that is 1.3 which is 1.5. So refractive index of glass medium is heavy as compared to water medium. So in this case, when light traveling from this medium behave as a denser and this medium behave as a rarer medium. If we compare these two medium, so in this case when light traveling from denser to rarer medium, then it away from the normal or deviate from its original path. That means it travel, this is original path, suppose it travel this direction. Clear? And in this case we have to use travel in this direction, and this refracted ray appears to meet at this point. Suppose this distance is d dash. Clear? At that time this distance is d. This distance is d. If you imagine only for glass medium, so at that time we can use the concept, that is d dash by d equal to mu2 by mu1. And here what is mu2? Second medium, this medium. So here we can write that is mu2 of refractive index of mu2, this medium. Mu2 means refracted ray traveling which medium. If we observe only two medium, and this is refracted ray whose refractive index 4/3, and here that is 4/3. Similarly mu1, incident ray traveling which medium, that is 3/2. If you find the value of d dash equal to mu2 by mu1 into d, and here 4/3 into mu1 divided by mu1 means 2/3 into d, and the value of d which is equal to thickness to 6 centimeter. Clear? So 3 to the 6, then 2 to the 4, 16 divided by 3. So this is d dash centimeter. Clear? This is apparent depth for this two medium. Now if the distance is d dash, and now we observe from this point, if we observe from this point, then this distance is d dash, then at that time this total distance, because all the distances are measured from the surface. So now object is here, and this object behave as a virtual object for the eye. Clear? This is virtual object. That means this object is now is here, and this total distance, suppose this is real depth. Now this is observer this point, and this is here we have, that is glass medium, water medium, and there is a object, and this distance is now, that is d dash, and d dash equal to 16/3, this distance. But if we observe this point, we have to measure all the distance from its surface. So this distance, suppose d1. Clear? If the distance is d1, Now d1 equal to this distance plus this distance. So this distance is given that thickness 4 centimeter plus 16 by 3. So we get d dash. If we use here the d dash by d equal to mu 2 by mu 1, then in this case the ray which traveling this medium, and you have to use this concept here. Clear? And this is initial ray. Now if we extend the refracted ray which incident this point, and now we have to draw a normal here when light traveling from denser to rarer medium, because rarer medium or refractive index 1 and here water medium refractive index 1.3. So this is denser and this is rarer medium. In this case this is denser and this is rarer, but in this case light traveling from denser to rarer medium, it bends away from the normal, and this ray appears to meet this ray which appears to meet this point, and this is final image. This final image which is equal to I. Clear? So if we use this concept here, that is d dash equal to, sorry, this, you can write this is d double dash. Here d dash by d equal to mu 2 by mu 1. D dash equal to this distance, and this distance, suppose this distance if we take d double dash, then we can write d double dash by d. D means this distance is real depth, and real depth here d1. We can write that is d1, which is equal to mu 2. Refracted ray traveling which medium? For air medium we can write that is 1 by mu 1, means incident ray. If we compare to this surface, then incident ray traveling water medium of refractive index 4 by 3. Clear? So we have to find the value of d double dash, and d double dash, so which is equal to here the double dash equal to 3 by 4 into d1, and the value of d1 which is equal to 3 4s are 12 plus 16 by 3 which is equal to 8, and 112 divided by 3, 28 by 3. So here 28 by 3 and 3 cancel, 4 7s are 28. Sorry, 28. D double dash equal to 7 centimeter. This is the distance from the observer. If we observe from this point, then this is the apparent depth. But according to question, what is the apparent position of an object below the rectangular block? Below the rectangular block, this distance, we have to find this distance, because this is final image here. So we have to find this distance, because total thickness 10 plus 4, because total thickness here, total thickness which is equal to 10 plus 6 plus 4 centimeter which is equal to 10 meter, and we have to find this distance, means normal shift, and normal shift here total distance, that is 10 minus this apparent depth which is equal to, we already find, that is 7 centimeter. Now answer is 3 centimeter. Y equal to 3 centimeter. Clear? So by using this concept you can solve different type of problem regarding apparent depth and real depth. Now you can solve one more conceptual question. Suppose there is a surface which separating by two medium, and its suppose refractive index that is √3, and here this medium of refractive index you can take, that is mu equal to 2, refractive index 2 and refractive index here, that is mu equal to 3. This is 1 and this is 2, and here two rays are coming this direction. This is 1, and suppose if we draw a straight line here, and these two rays are appears to meet this point. Suppose another ray this direction, clear, appears to meet, and this is known as object. And which type of object is this? This is virtual object. Here O is virtual object, because these two rays are actually not meet at O, there appears to meet, so it is known as virtual object. At that time, if we observe here, if we observe from this side, this medium, then find out, suppose this is air medium of refractive index 1. If you observe this side or air medium, then what is the apparent depth of the object? Because this distance is, suppose this distance is given that it is 16 centimeter. Clear? So if we use here relation, that is d dash by d equal to, that is mu 2 by mu 1. And what is mu 2? Mu 2 means refracted ray traveling which medium. What is mu 1? That is incident ray traveling which medium. So what is d dash? Apparent depth and d. And d is here, that is 16 centimeter. Why? Because here the object, and this is known as virtual object. Okay, now question, we have to find d dash. Clear? When this incident at this point, now we have to draw a normal here, and when ray traveling from rarer to denser medium, then it bends towards the normal. That means it travel this direction and meet this point. Similarly, if we draw a normal here, then this is the actual ray, and light traveling from rarer to denser, it bend towards the normal, and then this ray meet this point. And this distance is known as, that is apparent depth. Clear? So we have to find the value of d dash. So d dash equal to mu 2 by mu 1 into d. And what is mu 2? Mu 2 means refracted ray traveling which medium? This is refracted ray, and this is for refracted ray which traveling in second medium, this medium. This is not first medium. We have to always consider refracted ray traveling which medium, and its refractive index mu 2, and this is second medium of refractive index, that is root 3. So you can write root 3 divided by mu 1. Incident ray traveling which medium? That is 1 into here, that is d means real depth which is 16 centimeter. You can write here 16 centimeter. Clear? So this distance d dash equal to 16 root 3 centimeter. This is apparent depth. Clear? Okay. d dash equal to 16 root 3 centimeter. Suppose if we another case, if we take another case, and there is a liquid medium, this medium is liquid medium, and there is a object at this point in air medium. Clear? Suppose this distance is 12 centimeter. Now if we observe this point, now observer is here, there is observer, and it is situated at a distance of 16 centimeter. Clear? This is 16 centimeter, and suppose this water medium and refractive index 4 by 3, mu equal to 4 by 3. Find the apparent depth, or find the distance of the observer to image distance. Clear? So in this case, now we need two rays. Now the first ray traveling this direction, and this is air medium. So this ray should be paraxial, because this relation is only valid for paraxial ray, and this is incident ray, incident at that point, and this is the line of action. But when ray traveling from air to denser, rarer to denser medium, it bend towards normal like this direction. Clear? Appears to meet this point. Similarly, if we take another ray traveling this direction, incident, and which incident on the interface, and this is line of action, but when traveling from rarer to denser medium, it bend towards normal like this direction. Clear? This is refracted ray, this is refracted ray, and this is incident ray. And this distance, you always remember one thing, distance always measure from the interface or surface. This is surface. So this distance is known as d, means real depth. So you can use here relation. This is another question. So d dash by d equal to, that is mu 2 by mu 1, and here d dash equal to mu 2 by mu 1 into d, and the value of mu 2 means refracted ray traveling which medium? This is refracted ray, and refractive index 4 by 3. So you can write here 4 by 3 divided by 1 means incident ray traveling which medium? Air medium, and its refractive index which is equal to 1. So you can write 1 into D. What is D? This total distance is not D. Distance always measure from the surface to observer. Sorry, surface to object. This distance is 12 centimeters. So we can write here 12. So this is 1 and 3 4 are 12 and 4 4 are that is 16 centimeter. That is D dash. Clear? And here the final image, and this is object and this is refracted ray. If refracted ray traveling this direction, they diverge to each other. So they appears to meet. That means they appears to meet in this direction. They appears to meet this point. So this distance is known as D dash, which is equal to 16 centimeter. Obviously, a distance is greater than 12 centimeter, and this object image is known as, that is, virtual image. Okay, this is real object because two rays coming from this point, and this image is known as virtual image. Here the object is virtual object, but image is I equal to here, that is real image. So here the total distance from the observer to image, final image, which is equal to 16 plus here also 16. So total distance from image to eye or observer, which is equal to 16 plus 16, which is equal to 32 centimeter. This is the concept. By using this concept, you can solve different type of problem. Again, there is another question. A velocity of light in glass, which is equal to, for glass medium, that is V equal to 2 into 10 to the power 8 meter per second. In air medium, that is C, speed of light in air medium, that is 3 into 10 to the power 8 meter per second. By how much would an ink dot appears to be raised when it covered by a glass plate of 6 centimeter? That means there is a ink mark or dot point, and if we cover a glass slab, by how much would an ink dot appears to be raised when covered by a glass plate? If we cover by a glass plate like this, and its refractive index, first we have to find its refractive index, then its thickness, a thickness of the glass plate, that is 6 centimeter. So this is air medium and this is glass medium. Now we have to find here that is by how much or dot appears to reach. Appears to reach means this is initial. If you observe this point, suppose if you observe here the ray which incident normally on the interface traveling on deviately, and second ray if traveling this direction at certain angle, but this is paraxial, when it traveling from denser to rarer medium, it bend away from the normal, that means this direction, and here this appears to meet this point, and this distance is known as, that is D dash, and this is known as appears to meet, that is Y. Normal shift, here object or dot point appears to meet Y distance, and this Y distance is known as normal shift here. So first we have to find refractive index of this medium, but we already know a relation, that is mu equal to C by V, velocity of light in air medium divided by velocity of light in glass medium or on that medium, which is equal to refractive index. So in this case, that is mu equal to C, 3 into 10 to the power 8 divided by here 2 into 10 to the power 8, it cancel, that is 1.5 mu, which is equal to 3 by 2. So here refractive index of this medium, which is equal to 3 by 2. Now we have to use the concept, that is D dash by D equal to mu 2 by mu. And what is mu 2? We already discussed. Mu 2 means refracted ray, mu 1 means incident ray, and all the distances are measured from the interface which separating by two media, and this is air medium and this is glass medium. So in this case we can write D dash equal to, that is mu 2 by mu 1 into D, which is equal to D dash. Mu 2 means second medium, air medium, and its refractive index we already know, that is 1. So 1 by mu 1, which medium? Glass medium, and we get refractive index, that is 3 by 2. 3 by 2 into D. D means this real depth, and here 6 centimeter into 6, which is equal to 2 by 3. 2 by 3 into 6, then 3 2 is 6, which G dash equal to 4 centimeter. This is apparent depth. Clear? This apparent depth means this distance is image distance from the surface, and this distance is 6 centimeters. Sorry, this distance, because here image, final image we get at this point. So this distance is 4 centimeter, and if total distance 2 centimeter, if total distance 6 centimeter, then this distance is appears to meet. So we have to find the ink dot appears to reach. That means y is here. This distance appears to reach. Appears to reach or normal shift. Normal shift we can write, that is d minus d, and d is 6 minus 4 equal to 2 centimeter. Now we have to solve these two questions, and this two question is based on the critical angle and total internal reflection. So what is the condition of total internal reflection and what is critical angle? Before start these two questions, first suppose if we take one example, suppose there is a interface which is separating by two medium, and this medium is suppose air medium, and this medium is another medium of refractive index, whose refractive index √2. Clear? And this is normal, and which is perpendicular to this surface. This is interface separating by two medium. Suppose this is medium 1 and here that is medium 2. Now the incident ray traveling this medium, clear, and traveling the air medium. Now we have to find the critical angle in this case. So what is critical angle? Here we have to use sign convention. Critical angle means for a particular angle of incident, the angle of refraction should be 90 degree. That means if this angle is critical angle, then angle of refraction should be 90 degree, and this angle is known as R, which is equal to 90. This is the concept of critical angle. If we use here concept, that is mu1 sin I equal to mu2 sin R. What is mu1 sin I? Incident ray traveling which medium? Refracted ray traveling which medium? And this is incident ray. So here refractive index mu2, that is √2 into sine, and I is here, which is equal to C. Critical angle sin C equal to mu2, that is refracted ray traveling which medium? Means air medium, and this medium of refractive index 1. So 1 into sine R, and angle of refraction 90 degree. So you can write here sin 90. So here √2 into sine C equal to 1, and sine C equal to 1 by √2, and C is here, that is we can write 1 by √2 equal to sine 45 degree. So C equal to 45 degree. So here critical angle of this two interface is 45 degree. If angle is just greater than 45 degree, suppose if we incident another ray which is just 45.00001 degree, that means just greater than critical angle, then there is total internal reflection. At that time this surface is behave as a reflecting surface. This is the concept of total internal reflection. So by using this concept we have to solve these two problem or two numericals. So first numerical, given that the critical angle for glass air surface, calculate the critical angle for glass air surface if a ray of light which is incident in air on the glass surface deviate through 15 degree. That means suppose there is two medium, this medium is glass medium and this medium is air medium. There is a ray which incident in glass medium, incident ray traveling air medium and incident on the surface of glass medium, and its angle of incident suppose I, and here, and which is incident in air on the glass surface is deviated through a 15 degree. 15 degrees means this is a line of action, this is actual ray traveling this direction. When it traveling from rare to denser, it bend towards the normal, so this angle is R, known as angle of refraction. So according to question, R equal to 15 degree here. Then when an angle of incident already given I equal to 45 degree. So we have to calculate critical angle. So what is critical angle? Critical angle means we already know, that is sin C. we can write sin C equal to 1 by refractive index of denser medium. This is denser medium, and we have to use this formula. So what is refractive index for this medium? First we have to calculate refractive index of this medium. Clear? Okay, now we have to solve here. If you calculate this is angle of incident, angle of refraction. Okay, now this is air medium of refractive index 1. If we use Snell's law at point A, what is Snell's law? Mu1 sin I, which is equal to mu2 sin R. Refractive index of first medium, this is refractive index of second medium. So here mu1 sin I, mu1 which is equal to 1 into sin 45 degree equal to mu2 refractive index of denser medium, second medium, into sin or angle of refraction. Sorry, here given that this is surface deviated, sorry, this is deviation, not refraction angle. This is deviation angle delta equal to 15 degree. This angle is deviation means from its deviate original path. How much is deviate from its original path? That is known as angle of deviation delta, and delta is given here 15 degree. Both these two angles are vertically opposite angles, so angle of incident I equal to R plus delta. That is R plus delta, and R equal to I minus delta. I is here, that is 45 degree minus 15 degree, which is equal to 30 degree. So angle of deviation, sorry, refraction, which is equal to 30 degree. So if we use here sin R equal to 30 degree, now mu D equal to sin 30 value 1 by 2 and 45, that is 1 by root 2. Clear? So if we multiply here, that is mu D equal to 2 by root 2, which is equal to 2 root 2 by 2, and 2 cancel. That is the refractive index of this glass medium, which is equal to root 2. But we have to calculate critical angle of this medium. So critical angle, which is equal to sin C equal to 1 by mu into 1 by refractive index of denser medium. So 1 by, that is root 2, and which is equal to sin C equal to 1 by root 2, and which is equal to sin of 45 degree, and sin cancel. So C is here 45 degree. We already know in case of a glass slab, angle of I equal to angle of emergent ray. Clear? So you can use this relation here. So this angle is emergent angle when light traveling from denser to rarer medium. At that time critical angle equal to C equal to 45 degree. So in this way you can calculate the critical angle of the medium, separating by two medium. Clear? Now there is another one question. The light ray incident on the prism as shown in the figure, and its critical angle is 45 degree, given that its critical angle C equal to 45 degree. Now show the corresponding refracted ray and emergent ray. Now we have to show here refracted ray and emergent ray. So in this case, when light ray incident ray traveling air medium and strike on the interface, which separating by two medium, glass medium and air medium, or its refractive index, suppose mu, we have to calculate mu, refractive index mu here, and when incident normally it travels on deviatingly this direction and meet this point, this is refracted ray. So first case, here deviation is 0, so here delta 1, so delta 1 equal to 0. This is solution part. There is no deviation when it strike the first interface or first side of the prism A, B. Second, next, now we have to draw a normal here at the point of refraction, this point incident point. So we have to draw a normal, this is normal. Now here critical angle is 45 degree. If angle of incident is greater than 45 degree, then it is the condition of total internal reflection, and total internal reflection possible when the ray traveling from denser to rarer medium, not rarer to denser. So always denser to rarer medium. This is the case of denser to rarer medium. So first we have to check here what is the angle of incident. This angle is also 90, 45. Then this angle must be 45 degree. In a triangle, 3 angle, addition of 3 angle is equal to 180 degree. So this angle is 90 degree because this is normal. This normal is perpendicular to this interface. So this angle 90 degree, and this angle must be 90. already this angle 45, so the remaining part which is equal to 45 degree, and here this angle is 45 degree and this angle is known as angle of incident, which is equal to critical angle. So what is the condition of critical angle? If a ray which incident at its critical angle, then reflected ray traveling on its surface at that is r equal to 90. That means this angle is 90 degree. When ray traveling from denser to rarer medium, and its critical angle is now 45 degree and incident also 45 degree, it travel on the surface this direction. This is refracted ray, and it deviate from this path which is equal to r. This means r, angle of refraction here, r equal to 90 degree. So first question complete. So corresponding refracted ray, this is refracted ray, and emergent ray, this is emergent ray, which lies on the surface, or it is known as grazing ray. Now second question, find refractive index of the prism. We have to find refractive index of this prism. So how can we find refractive index? Here this is air medium. Suppose this point is point B. We can take this point is x. Now if we use Snell's law, this surface or ABAC interface or at point x, then in this case we can use that is mu1 sin I, which is equal to mu2 sin r. What is mu1 sin I? First you have to choose one interface. This is an interface. Second thing, sin I means incident traveling which medium? For this interface, this is incident ray and this is refracted ray. So incident ray traveling this medium and its refractive index mu. So can write here mu into sin I, angle of incident, which is equal to 45 degree, equal to mu2 means air medium, and here refractive index 1. So mu2 equal to refracted ray traveling which medium, means air medium of refractive index 1 into here that is sin r into sin r, angle of refraction, which is equal to 90 degree. Sorry, here okay. So here mu, we have to calculate mu. Then refractive index of glass, this is 1 by root 2, 1 by root 2, which is equal to sin 90 value equal to 1. Now mu equal to the refractive index of this medium, which is equal to root 2. Clear? Now find total deviation after 2 refraction. First refraction, deviation 0. For second refraction, actually this is the actual ray. This is actual ray traveling this direction. Due to interface, it changes its direction in this direction. So this is delta 2. Clear? This is known as delta 2. So total deviation, but this angle is 45 degree and this angle must be which is equal to 48 degree. So here we get delta 2, angle of deviation while it strike interface AC 45 degree. Now this is clockwise direction, there is no deviation. First case deviation 0, second case clockwise, this is clockwise direction. So total deviation which is equal to delta 1 plus delta 2, 0 plus 45 degree. So total deviation which is equal to 45 degree. So now let's start another one question. This is important question. There is a prism, its angle, these two base angle are equal, that is 15 degree and 15 degree, and angle of prism which is equal to 150 degree. There is a ray which is traveling in air medium and incident on the interface AB at an angle 60 degree. Now you have to find total deviation after suffering number of refraction. You have to find total deviation. So and its refractive index of this medium or prism, which is equal to root 3. Here refractive index of this medium or prism, that is root 3. Now we have to find here total deviation. So this is the initial ray traveling this direction. This is line of action. When ray of light traveling, if you imagine this surface which separating by two medium, air medium and denser medium, light coming from rarer to denser medium, it bend towards the normal, because this is normal, and strike this here. Sorry. and which strike this point, and this is deviated from its original path. Suppose that is delta 1, and this angle is known as angle of refraction r here. So we have to find angle of refraction r. If we use this point, suppose x, at x, if we use Snell's law, that is sin I mu 1 sin I, which is equal to mu 2 sin r, mu 1 air medium and refractive index 1 into sin I sin 60 degree equal to mu 2 here refractive index of second medium, that is root 3 into sin r. Clear? And this value, that is root 3 by 2 equal to here root 3 into sin r. Root 3 cancel. So sin r equal to 1 by 2, which is equal to sin 30 degree, and the value of refraction through first surface or surface AB, which is equal to 30 degree. Clear? So we get the angle of refraction which is equal to 30 degree. If this angle 30, we already know this total angle equal to this are vertically opposite angle. So sum of, so we can calculate here, that is angle of incident equal to r plus delta, and delta equal to I minus r, and I is here 60 degree minus 30 degree, which is equal to 30 degree. So angle of deviation delta is here 30 degree in clockwise. This is clockwise direction, that is clockwise direction. Clear? Or WC we can write clockwise direction. Okay. Now second, if this is root 3, then question may arise here, if we draw a normal this point, if this angle is now this angle is 90. Clear? If we draw a normal this point is here, then this angle is 30 degree, this angle 30, so this angle is 90. Here this angle 30 degree, this is a triangle, and you know three angle of the triangle which is 180 degree, this is this angle is 90 and this angle 30. 90 plus 30, which is equal to 120. 120 plus 15, 135. So 180 minus 135, which is equal to 5, and that is 45 degree. So this angle which is equal to 45 degree, and this angle must be 45 degree because this angle 90 normal, this is normal N2, this is normal N1. So this angle also 45 degree. Here this deviation, this is delta 1, and this angle equal to 45 degree. Now question may arise here, when ray traveling from denser to rarer medium, it is the possible case of total internal reflection. So first we have to calculate critical angle here. So what is critical angle? We already know sin C equal to 1 by mu d. When light traveling from denser to rarer medium, this is denser to rarer medium, this direction, then if there is possible any critical total angular reflection, first we have to find critical angle. So sin C equal to, here sin C equal to 1 by mu d, refractive index of this medium, which is equal to 1 by root 3, and the value of 1 by root 3 in terms of sin function, we already know the value of, it is sin root 2 or sin 45 degree, which is equal to 1 by 2 we can write, or the value of 1 by 2 which is equal to sin 45, and its value 1.7 is value 1.2. So its angle nearly equal to, you can imagine this angle sin C, the value of sin C, which must be less than 45 degree. Here C is less than 45 degree, or if you find this value nearly equal to 36 degree, this is your trigonometry table. So you have to imagine, if this angle 45 degree and its value 1 by root 2, then what will be the value of 1 by root 3 if you compare to this relation, this two relation, then this angle C must be less than 45 degree. Clear? Here 1 by root 3 and this value is 1 by root 2. So here critical angle is less than 45 degree, and this angle is here, that is 45 degree. This angle is 45 degree, That means if this angle is less than 45, suppose here critical angle less than 45, so can take suppose 40 degree example, or imagine this angle is 45, actually this angle 35 point something or 36, suppose 45 degree. That means the angle of incident here which is greater than this critical angle. This is incident angle. Here incident angle I which is greater than C, because this angle if we take 40 degree, then this angle is greater than 45 degree here. So in this case there is total internal reflection. So this ray traveling this direction, in this direction, and this angle also 45 degree. Clear? Now look at the diagram. So there is no deviation. Why? Because this surface now behave as a reflecting surface, and this ray reflected towards this direction due to total internal reflection. Now we have to draw a normal at the point of intersection here, this point. You have to draw a normal at this point. Okay, if this angle also 45 degree and this angle 90 degree, this angle 15 degree, 15 plus 45 60, this angle 90, so 90 plus 60 which is equal to 150 degree, and this is a triangle, this triangle, and angle of this angle, this angle, this angle must be 180 degree, so this angle is here, that is 30 degree. Clear? So here angle of incident which is 30 degree. If we choose this point Y for Y point, at point Y, in this point angle of incident which is 30 degree, and this angle is less than critical angle, because here critical angle, this angle I which is less than this critical angle. So when light traveling from denser to rarer medium, there is no total internal reflection. So this is the direction of incident ray or line of action of this incident ray. Now when light traveling from, if there is no total internal reflection, then light traveling from denser to rarer medium and it bends away from the normal, means this direction. Suppose this is emergent ray and this angle is known as total emergent ray or emergent angle, you can write that is E. If we use Snell's law here at this point, so mu1 sin I equal to, that is mu2 sin R, and here mu1 means incident ray traveling this medium, because here now this is interface separating by two medium, this is incident ray, and here mu1 which is equal to root 3 into sin I is here 30 degree, 30 equal to mu2 means air medium 1 into sin R, and here that is root 3 into the value of sin 30 which is equal to 1 by 2. Now this is sin R, and sin R equal to root 3 by 2 and root 3 by 2 which is equal to sin 60 degree. So here R, sorry, this angle is E. So you can write here this R, this is not R, this is E, and here E, and this angle of emergent E equal to 60 degree. Clear? Okay. If this angle is 30, then this angle also 30 degree, because this is line of action. So this angle also 30 degree, and this angle must be deviated, that is delta 2 equal to 30. 30 plus 30 which is equal to 60 degree. So here delta 2 deviation which is equal to 60 degree, and in this case deviation delta 2 which is 30 degree, and it is also clockwise direction, it deviates from its original path in clockwise, sorry, this is not WC, clockwise direction W2. So there is two deviation W1 and here deviation W. So total deviation which is equal to delta 1 plus delta 2, that is 30 degree plus 30 degree which is equal to 60 degree. So total deviation after suffering number of refraction which is equal to 30 degree. Clear? So this is all about refraction through glass slab. What is the difference between real depth and apparent depth, and the critical angle, total internal reflection problem. Clear? Thank you.